Hello everyone, welcome back to another discussion in our critical reasoning course. In this video lecture, we're going to start talking about and introduce some of the most important and foundational concepts and aspects as it relates to propositional logic. So in this video, we're going to focus on 6.1, dealing with symbolic notation and how to translate different ordinary English statements into symbolic form, and think about the different logical connectives that we'll be using for the next couple of modules. I also want to just let you know that this material comes directly from my logic course when I teach Introduction to Logic. These are some of the aspects that we deal with in that class. And now we're just going to be applying these same principles, same ideas to critical reasoning. So with that in mind, I should let you know the handouts that you have available for these next couple of modules will be super important. I highly recommend that you pay close attention to these handouts. In fact, they are the same handouts that I use when I teach Introduction to Logic. In fact, you might even notice that there is some information at the top of this first handout dealing with Aristotelian logic or categorical logic. And that's because it comes from this other class. So I say, previously the logical systems we were working on focused on primarily categorical terms, so on and so forth, talking about Aristotle. You can ignore that bit at the very beginning of this first handout. Instead, we're going to kind of skip past that because that's just reminding my other students of what we had done previously in the semester. What we're going to do is we're going to jump right into some of the most important terms, concepts, and how they get applied as it relates to propositional logic, sometimes thought of as in terms of sentential logic and natural deduction. So now, as it relates to propositional logic and natural deduction, let's begin with the very most basic concept. That's going to be what we are going to call an atomic sentence or an atomic statement. So what do we mean by this? Well, remember, we are talking about statements insofar as these are the sorts of things that can be either true or false. They're truth apt, right? So we still are using that same notion of a statement. But here, we're making it more specific insofar as we're talking about these very, very simple atomic statements. And so literally think about it in terms of like little atoms, little bits of atoms that then can be used to compose larger molecules and chemical compounds and so forth, right? So that's kind of the same sort of thing that we're talking about. We're talking about these very basic units of logic, what we're calling an atomic statement. So these atomic statements, they don't have any logical connectives, right? So I'll need to explain what exactly I mean by a logical connective here in a second, right? So they've got these logical statements that are atomic. They're very basic, very simple, because they lack any sort of operators, any sort of connectives, or anything that's logically changing the atomic statement. And then we want to contrast that with what we might call compound or complex statements. Right? So a complex statement or a compound statement is going to be made up out of the smaller basic atomic or simple statements. So these complex statements are going to include multiple atomic statements. And those multiple atomic statements will be connected together, logically connected with one of our logical connectives. Right, so we've got to have at least one atomic statement, and also we've got to have a logical connective. So we've got to have at least one atomic statement, and there has to be at least one of the logical connectives. Right, so you can think of these compound or complex statements as being made up of or composed out of both the atomic statements that we have, as well as the logical connectives that literally combine them together or connect them in some way. Now, as it relates to our atomic statements, we are going to symbolize these atomic statements using different letters. So for instance, I might use a P or a Q, I might use an A or a D. But the basic idea when we're using these different letters is that we want them to do a good job of representing what the actual statement says. So for instance, on the handout, I've got this example. David is a philosopher, right? David is a philosopher, right? So that statement, this statement is going to be an atomic statement. It's a simple, basic statement. It doesn't have any logical connectives in it. And so we can just call this D for David. You could call it P for a philosopher if you want, but either way is fine, as long as you're being consistent all the way through the proof, as we will eventually get to it. The other thing to keep in mind is once you've used a letter to symbolize some atomic statement, you can't repeat it again. You have to use the same letter only with regard to that atomic statement. So if you have some other atomic statement, you have to use a different letter to symbolize it. Here is another example. James Joyce wrote Ulysses. James Joyce wrote Ulysses. Right? So with regard to this particular atomic statement, we might just symbolize this as, I don't know, how about just U for Ulysses? I suppose if you wanted to, you could symbolize it as saying, as using J for James Joyce, or like I said, you could just use U for Ulysses. Another example that I have from the handout here is the bluefin tuna is facing extinction. Right? So on the handout, I've just decided to symbolize this as B. B for bluefin tuna. Again, these are basic atomic statements because they're, even though it's, it seems like it might be complex, you've got multiple words here, the meaning is somewhat complex, but nonetheless, the actual form it takes is simple, right? We're just saying something about the bluefin tuna, namely that it's facing extinction, right? So given that there is no logical connective involved, it's a very basic unit of logic. It's what we're calling an atomic statement. Finally, I have an example that says, the Huskers are a football team, right? And so the way that I've symbolized this is I've just given it this letter H. So again, it's a very basic unit of logic, what we're calling an atomic sentence, because it doesn't have any logical connectives in it. Now what I need to do, I need to show you exactly what I mean by a logical connective. And by doing that, I hope to make it clear why these statements don't have any of those logical connectives. So let's go ahead and do that. All right, it turns out that there are going to be 5 logical connectives that we are going to pay attention to and use. I'm not going to introduce, at this point at least, any universal quantifiers or existential quantifiers. We're just dealing at the very beginning with these very basic units and how they get connected together. These atomic sentences, like James Joyce wrote Ulysses, how we might combine that with something else. So there's going to be 5 that we need to pay attention to. The first one is called negation. All right, so we're going to symbolize negation using what's called the tilde, which looks like this. It's just this little squiggle mark, right? So if I have some, let's say I'm talking about David is a philosopher, and I've got a D, well, I can negate that D with the tilde. And when I do that, it actually changes the meaning of D. It ends up meaning David is not a philosopher. Or more specifically, it is not the case that David is a philosopher. Right? So that's our first one that we're introducing. It's the basic negation, which means not, or it is false that, or just we're saying it is not the case that David is a philosopher in this case. Right? So that's the tilde. It's going to be our symbol that we use for negation. Now on your handout, at the bottom of the handout here, I've also given some alternative forms of negation, as well as all the other 5 connectives, but we're just going to focus on the one that's under the second column. But I've provided it for you because if at some point you continue on and do more logic, or if you have a chance to work with these concepts in more detail, you might see negation used in a different way. Sometimes it's called like this hammer thing here. All right, so I'm going to draw a line here. This side is what we are going to focus on. This side will be the alternative. All right, so now let's introduce the second logical connective. That one is conjunction, which basically means and. And we're going to use the symbol dot to use for our notation of what the conjunction represents. All right, so number 2 is conjunction. And this symbol is just a simple dot. It just conjoins together two atomic statements. Alternatively, sometimes people use this little upside down V, or sometimes people use the ampersand. So those, again, are alternative symbols that you might come across at some point. But we're going to use the dot. That's going to be the symbol that we use for this class. Now, that basically means that we're conjoining two things together. So for instance, I've got D and I've got U. So I could potentially join those things together, D and U. Right? So now what I've done is I've taken two atomic statements and I've conjoined them together with the and conjunction, and now it becomes a compound or complex statement. All right, so our third logical connective is called the wedge, and it stands for disjunction. Or sometimes I like just to think of this as or, right? So that is just your simple V, like this. Right, so that's usually the way that's symbolized. I've never really seen it symbolized as anything else. I like to think about it in terms of like a person is raising their hands. They're saying it's either this or it's that, right? It's that or it's this. So it's like a person with their arms raised up in the air, either pointing that way or pointing that way. And it means or, right? It's a disjunction, right? So what that means is I can put the D and the U together using conjunction, or I can disjunct them. I can say D or U. All right, so now our fourth logical connective is going to be the horseshoe, which stands for conditional. It's going to be the if-then statement. Right, so this is the conditional. And the symbol that we're going to use is the sideways U, or just called the horseshoe sometimes. So that's our conditional. Sometimes people will symbolize it with an arrow, maybe like that, or just like this. Either way is fine with me. But for our purposes, we're going to use this horseshoe or sideways U, if you will. Now, what is the conditional? Again, it's our if-then statement. If A, then B. If today is Wednesday, tomorrow is Thursday. If you're hungry, then you should eat food. Right? These are our if-then statements, which are basically just conditional statements. Again, we can symbolize this. I can say, if D, then U. Right? If David is a philosopher, then James Joyce wrote Ulysses. Right? So I can connect these different atomic statements together using this logical connective of the horseshoe, or the conditional statement. Now, another way that sometimes philosophers think of the conditional statement is as implication. Right? So we might say D implies U. Right? If you have D, then you will also have U. D implies that U is the case. Right? So sometimes it's also called implication. All right, so now let's introduce our fifth and final logical connective, which is called equivalence, or sometimes referred to as the triple bar. Right? So here it's the triple bar. There are sometimes when people use a double arrow like this. Either way is fine, but for our purposes, we are going to use the triple bar. And again, the equivalence, basically, it's putting together two conditional statements. Sometimes we say if and only if, right? So it's a very, very strong kind of equivalence. Basically, it says the equivalence goes in both ways. If D, then U. If U, then D, right? So that's why we say if and only if. So this is going to be the fifth and the final logical connective that we are going to pay attention to for this class. So in the next video, we're going to look at some examples to make sure that we understand how all of this information is working, how we can translate different statements into symbolic form, and we want to make sure that we understand what counts as a well-formed formula. Sometimes these are called WOFs. A well-formed statement. Another way of putting that is we want to make sure that we are using these logical connectives to create complex or compound statements. We're using them correctly, because if we're using them incorrectly, then we won't be able to do much, logically speaking, with them. So that's what we will turn to in the next video.